Hey everyone! Today, we are diving into a fascinating discovery that's been making waves in the world of paleontology. In 1999, a dinosaur bone was found on Japan's Fukushima coast and left unstudied for over 2 decades. Fast forward to 2026, and scientists finally identified it as belonging to a 3-meter-long iguanodontian that lived 90 million years ago. This story is a testament to the power of patience and the importance of revisiting old findings with fresh perspectives. Let's break it down. First off, the journey of this bone from discovery to identification is a fascinating one. The fossil was found on the grounds of the Iwaki City Ammonite Center in Fukushima Prefecture, within the Ashizawa Formation, a group of rocks formed in a shallow marine environment during the Upper Cretaceous period. At the time, it was tentatively identified as a sternal plate belonging to a hadrosauroid dinosaur. But here's where the magic happens. Scientists revisited the bone in 2026 with modern analytical methods and detailed comparisons, revealing it to be the right sternal plate of an indeterminate Styracosternon, a more advanced group of Iguanodontian dinosaurs. Iguanodontians were a widespread group of herbivorous dinosaurs that lived from the late Jurassic through the late Cretaceous. They were found across large parts of the ancient world and included a variety of body shapes and sizes. Some were relatively small and lightly built, while others became large, powerful plant eaters. Their teeth and jaws were adapted for processing vegetation, and many species could move on either 2 or 4 legs. The group is crucial for paleontologists because its fossils help explain how herbivorous dinosaurs spread between Asia, Europe, and North America during the Age of Dinosaurs, when these landmasses were part of the larger northern supercontinent known as Laurasia. Now, the Fukushima fossil is significant because most Iguanodontian remains found in Japan are fragmentary. Researchers have recovered isolated teeth, bones, and other incomplete remains, making it difficult to determine how many species lived in the region or how large they were. But here's the exciting part. The newly studied sternal plate points to a dinosaur of approximately 3 meters, much smaller than other Iguanodontian fossils previously found in the same geological formation. This suggests that dinosaurs of different sizes lived in the coastal environments of what is now Fukushima during the late Cretaceous. What's more, the discovery provides insights into the ancient coastal ecosystem. The rocks containing the fossil were deposited in a shallow marine setting, meaning the bone may have reached the coastal environment after the dinosaur lived on nearby land. It may have been carried by a river, washed by flooding, or transported through other natural processes before being buried in sediment. This supports the idea that Iguanodontians lived along the eastern margin of ancient Asia, close to coastal habitats and shallow seas. The region may have included a mixture of river plains, wetlands, vegetation-rich shorelines, and islands, supporting herbivores of different sizes, along with predators, marine reptiles, and other animals. The importance of body size in dinosaur communities is undeniable. Large herbivores might have been able to browse on taller vegetation or travel further to find food, while smaller animals could exploit lower plants, dense undergrowth, or places that larger dinosaurs couldn't easily reach. If there were several species of Iguanodontians of different sizes living in the same general area, they might have occupied different ecological niches, reducing competition and allowing multiple herbivores to coexist in the same coastal setting. The Fukushima fossil doesn't prove exactly how these dinosaurs divided their habitat, but it adds an important clue, suggesting that ancient East Asian coastlines may have supported more varied dinosaur communities than previously thought. Finally, this discovery highlights the value of museum collections and local fossil centers. A specimen collected in 1999 didn't need to be newly excavated to change scientific understanding. It only needed to be examined carefully. A small bone can reveal a lot about a vanished world, even if it represents just one part of a small dinosaur. It's a reminder that the fossil record is incomplete, and the most important evidence may not always come from a dramatic skeleton. Sometimes, it's hidden in an isolated bone, waiting decades for someone to recognize its significance. So, what do you think? Is there more to uncover in the fossil record? What other secrets might be waiting in museum collections? Let me know in the comments, and don't forget to like and subscribe for more fascinating content. Thanks for watching.